So we're going to have a look at a new topic, and we're going to start with some arcs and sectors. So a little bit of new words, a little bit of a new vocab. For two things that we're going to deal with, we're going to look at an arc, and we're going to look at sectors, hence the title, arcs and sectors. Now, an arc is part of the circumference of a circle, so it's part of the distance around the outside of a circle. They can be most of it, it can be a small part of it, they vary in size. And a sector is the exact same, except a sector is a chunk or a slice of the circle. Again, it can vary in size. Some could be larger, some could be smaller. Now, what we're going to start off by doing is we're going to try and find an arc length, first of all. And we're going to have a formula for it, but just before we look at the formula, I want to have a look at where it comes from. Now, if we were trying to work out the circumference of a regular circle, okay, arc length and circumference are similar. It's a similar idea. It's the distance around the outside. However, an arc length just isn't the full length around the outside. So if I was trying to find the circumference of a circle, I would use C equals pi times d. Now, if I was using a semicircle, or half of a circle, if I was trying to find the circumference of that, I would have a similar formula, but I would be halving my answer. And some that we've seen before, we even went down to a quarter of a circle, which again is a very similar formula, but I would quarter my answer. So it'll be a quarter of pi times d. Now, this formula is a very, very similar idea. The reason why I'm halving and the reason why I'm quartering is all to do with the angle at the middle. In a full circle, I have 360 degrees all the way around. In the semicircle, that's a straight line going through the middle, so I've only got 180 out of a total 360, which is a half. So that's why I'm halving my circumference. And for the last one, if I've only got a quarter of the circle, it's a 90-degree angle, and 90 out of 360 is a quarter. So every time, I'm actually multiplying it by whatever the angle is that I have out of the possible 360. So what we want to do is to be able to extend this, so we're not just dealing with halves and quarters, but we're being able to deal with different angles. And so as a generic form, we can say that any arc length is just the angle over 360, so that fraction of the full circle times pi d, which is my circumference formula. So if you are copying this as a note, please make sure you're copying this down. Otherwise, let's see this working. So I'm going to have arc length. Now, it's the distance from A to B is going to be equal to whatever the angle is out of 360 times pi times my diameter. Now, the angle there is 24 degrees out of a possible 360. I'm timesing that by pi, and I'm timesing that by my diameter. Now, that there is the radius, because it's going from the center to the edge, so I need to double it to get my diameter. Now, I can type this into my calculator, 24 divided by 360 times by pi times by 14, and that's going to give me 2.932, and it's a very long unrounded answer. I'm going to round it to 2 decimal places. Always make sure you're checking to see, does the question tell you what to round it to? If not, you can choose. Okay, I would always recommend 2 decimal places. And my units are centimeters, and I've rounded that to 2 decimal places. So I'm going to give you some for you to try, and please make sure you're trying these. There are only 3 there to get the most out of this video. If you watch this and then try the next 3 questions I'm going to show on the board, that will be the way that you get the most out of these videos. So please pause the video, please try these 3 questions, and then press play to see how you get on. So answers, again, it's vital that if you are attempting these questions that you are marking them just to check to see how you get on. Notice that the question said to round to 1 decimal place. Okay. Now, we're going to extend this a little bit further, and I want to get my screen cover. When we have these circles, there's not just one arc length, okay? There are actually two arcs that are being shown here. We have, from A to B, we have a smaller arc, but actually, we've also got a larger arc going around the outside. So there's actually two questions there. Now, I'm just going to call it generic names. So I'm going to call that one alpha, and I'm going to call this one theta. Now, we need to know, and we need to be able to distinguish between these two. So the arc that I've done in a yellow, that's a smaller arc from A to B. So what we say, if that's a small one, the one on the outside, the major arc, goes anti-clockwise from A to B. So the larger bit, the bit that's going around the outside, so that's the bit coming around here, we say that that's the major arc. And to calculate the length of the major arc, we would use the angle theta. At the same way, the minor arc is this small distance here. And to work out the length of the minor arc, we would be using this angle here. So we need to be aware which angle that we're going to be using depending on whether we're trying to get the major arc or we're trying to get the minor arc. So how that would work, in fact, the exact same strategy is what we've been using. However, it depends on the angle that you're going to use. So the major arc, so this is the big one coming around the outside here, and it's theta is that angle. So I would have theta over 360 times pi times my diameter. And if I was trying to get the minor arc, I'll change colors here. Remember, that's this small arc here, and if you're doing the smaller arc, you're going to be using alpha. So it'll be alpha over 360 times pi times d. It's essentially, if you're doing the major arc, you're using the bigger angle, and if you're going to be doing the minor arc, you're going to be using the smaller angle. So, some for you to try just here. It's a continuation of what we have just done. Okay, in each of these, it's asking you to calculate the minor arc. Okay, so you're being asked to calculate the minor arc. And again, answers to one decimal place. So please pause the video, take your time to answer these questions, then press play to mark and to see how you got on. Again, please make sure that you are marking. It's vital that you are marking your answers to check to see anything that you're getting wrong. Please go back, watch the video again, especially the bit at the start about the arc length, and then a bit about the major and minor arcs.